Everyone, welcome back to Math Tutoring. Today I'm going to show you step by step how to find the locus given some set of conditions, how you're going to set that out. But before we do that quickly, I just want to make a note. So all my videos from now on will be based on your comments. So if you have anything in maths from high school even to some university subjects, I want you to comment below, but also add the hashtag #NathMathTutoring so I know that's a priority, right? I will prioritize comments with that hashtag #NathMathTutoring and just comment with that hashtag what you want to see in these videos. And I'll be doing 1 to 2 videos a week depending on how many comments there are. If there's lots, I could probably do more. And I have the same concept on my fitness and nutrition channel, or my personal fitness channel. I'll leave a link so you can check that out if you have any fitness or nutrition tips you want. Otherwise, let's get back to the video. So here's the problem. Find the locus of P, x, y such that it is equidistant from A and B with those coordinates. So the first step we want to do is you want to draw the situation. What that means is get a diagram and draw what's happening. So A is about here, B would be around here, and P is somewhere, we'll put it up here. I like to put it far enough so I can see the whole picture. That equidistant, now equidistance means equal distant. That's just those two words combined together. So that means these lengths are equal. So that's step 1, draw the situation and especially mark the special condition they gave. The special condition was that these distances were equal, so let's mark that. So that's going to help us with step 2. Is write a math statement to summarize diagram. So in order to find a locus, which is an equation, we need to get some maths here. So what we're going to do is we're going to make a mathematical statement about this diagram. And the statement is that these distances are equal. So we can summarize that with saying PA equals PB. That's how simple this step is. And what I like to do is with distances is square them. So I square both sides because that means I won't need to use a square root, which is part of step 3. So by writing down step 2 properly, you have the mathematical statement you need to get the locus. You just apply appropriate coordinate geometry formula. Okay, that's pretty much it. So we want distance, so we're going to use the distance formula. I've put squared here so I don't have to write the square root. So distance formula is the difference in x values squared. So x minus 1 squared plus, and difference in y values squared, y minus 4 squared. So that's PA squared. A PB would be x minus 3 squared plus y minus 1 squared. So that is the equation of the locus, but that doesn't look like anything we know. So what we'll have to do is obviously expand and simplify. That's just a no-brainer, but let's do it. So make sure we know how to do perfect squares. So we square the first term, double their product, there's a minus here, and then square the last term. So you really make sure you're going to know how to do perfect squares, because we're doing a lot of perfect squares here. And it'll save a lot of time if you know how to do perfect squares quickly. Okay. So now we just simplify. So what you notice here is x squared appears on both sides, so they're gone. And same with y squared. They're gone. Right. So when you notice you have the same terms on each side, you just cancel them out. Right. So what we'll do is we'll notice now we have an x and y term on both sides. So that means it's going to be a straight line. So we'll bring everything to make x positive. So see, this is negative 2x, this is negative 6. So I want to bring that over here to make it positive. So it'll be 4x. Here I've got negative 8y, here I've got negative 2y. If I bring that over, that's plus 2y, so that's negative 6y. Let's look at the numbers. 1 plus 16, 17. 9 plus 1, 10. So 17 minus 10 plus 7 equals 0. So that is the equation of the locus of the point P that is equidistant from A and B. And finally, step 4 is optional depending on the question, is describe geometrically. So if we look here, I'm just going to put some dotted lines here. Now, in order to describe the locus of P, describing straight lines is actually harder than circles or parabolas. Alright, but let's look at the condition. In order for P to be equal distance from A to B, that means you'll have to go through the midpoint, right? Because this point is equal distance between both, so that means it goes through the midpoint. So if I draw this line here, so this is the equation of the locus. Doesn't necessarily go for the origin, it's just a bad diagram, obviously. And the next condition is this has to be a right angle. Oh, let me fix that up, a right angle. Right, because if it's not a right angle, if it's slanted at all, that means at one point, P will be closer to another point. So how we describe a straight line, it is what we call the perpendicular bisector. Right, because it's perpendicular and it bisects the line AB. So I'll just put perpendicular bisector of AB. Okay. So finding an equation of locus given special conditions is quite straightforward as long as you know your coordinate geometry formulas and can draw a good diagram. Okay, it's a really straightforward process, just take some practice, and that's it. So if you enjoyed today's video, make sure to smash that like button and comment below. Also, if you want any future math video, make sure to put the hashtag NAFMathTutoring with what you want the future video on. But make sure I haven't got a video on that already. Okay? Otherwise, don't forget to subscribe and turn on notifications for future videos, and check out my personal fitness nutrition channel, entertainment, if you need help with that.